All right, we're going to continue on with our sum and difference identities and solving. So you will need your unit circle. We're going to start with just simplifying our identities, and you'll notice that we're given the expanded version. So you want to look at this part here, which is our 5x and our 8x. So we know that it's tan 5x and 8x. We need to determine, is this the sum identity or is this the difference identity? So you want to look at the pattern of what the signs are on the identities that I've given you. And you'll notice that if it has a negative in the numerator, that matches with a negative in the equation. So this is our sum and difference identity. And then we will simplify what's inside the parentheses. And we don't leave a negative inside, so we'll use our even and odd identity. And then we're done. If we go to the next one, we look at what is our A and B value. We look at the pattern of cosine, cosine, sine, sine, and then we look at the sign in between. So if we match to our identities, it's going to be cosine. Because this is a negative, we're going to have a positive in the equation. So we're going to simplify. Now this one we actually end up with a particular angle. We did not end up with a particular angle up above. That's why we were done at this point. But we can actually find the cosine of 90 degrees. So what is the x value at 90 degrees? It is 0. So you keep going if you can. Now let's apply these sum and difference identities to actually solving some trig questions. We're given the domain of 0 to 2 pi, and I'm going to look at what I'm given. A lot of busyness here. So I'm going to first focus on this first part here. So we have cosine x cosine pi minus sine x sine pi. Well, that in itself can be simplified. So I'm going to do that first before I start working. I can't do anything with the cosine x, but I can simplify the cosine pi. So the first thing I'm going to do is I'm going to evaluate from the unit circle. And that's just because I'm already given some angles. So cosine x is going to stay the same. Cosine pi, so I go to the angle of pi, and then I look at what is the cosine, so what is the x value there? It's a -1. Then sine x is going to stay, because that doesn't have an actual angle. Sine pi, we go to the angle of pi. What is the y value? It's 0. Then I'm going to carry down that negative. I'm going to carry my parentheses. Sine x again times cosine pi. So cosine pi, what is the x value at the angle of pi? That's -1. Plus cosine x, that's carried down right here, and sine pi. What is the y value of pi? It's 0. So if I clean this up and simplify, so I have -1 times cosine x. So I'm just going to bring that negative to the front. I have 0 times negative sine, so 0 times anything disappears. Then I have a negative, which is right here. I have a parentheses, which is right here. If I simplify, I get negative sine x, and then cosine x times 0. I'm going to distribute my negative. Now, we can't change our cosine to be a sine, and we can't change our sine to be a cosine. So what do we do next? What we're going to do is I'm going to add cosine x to each side. So what is this saying? It's saying where are the y values equal to the x values, because sine represents y and cosine represents x. So where are the y value equal to the x value? So what angle? Notice that this is positive, this is positive. Okay, so another way to write this would also be negative sine x is equal to negative cosine x. Those would be equivalent as well, right? Because you divide both sides by a negative. So that means that if both of these are true, we're going to need an answer where cosine and sine, x and y, are both positive, and where cosine and sine are both negative. So x is equal to pi over 4 and 5 pi over 4. Why did I choose those angles? Well, at pi over 4, we have root 2 over 2 and root 2 over 2. So x is equal to y is equal to x. Cosine is equal to sine is equal to cosine. At 5 pi over 4, we have negative root 2 over 2 and negative root 2 over 2. Sine is equal to cosine, cosine is equal to sine. And those are our two answers between 0 and 2 pi. So just to be clear, the reason why we aren't using the second quadrant and the fourth quadrant is because one of our coordinates is positive and one of our coordinates is negative. So we don't use this one and we don't use this one. Next question. Cosine pi over 3 plus x plus cosine pi over 3 minus x. So the first thing we want to do is use our sum and difference identity to expand this. And the reason we want to do that is so we can actually evaluate this pi over 3. So we change this to be cosine pi over 3, cosine x minus sine pi over 3, sine x. That's the first identity. Then I'm going to carry down that plus sign, and then I'm going to do my next identity. Cosine pi over 3 cosine x plus sine pi over 3 sine x. And then the whole thing is equal to positive square root of 3 over 2. So this is sum and difference. And now I'm going to evaluate. So I'm going to use my unit circle. and I'm going to evaluate what is cosine of pi over 3. So what is the x value at pi over 3? So I go to my unit circle, and it is 1/2. Cosine x, I don't have an angle, so I just carry that down, minus what is the y value at pi over 3? What is the x value at pi over 3? What is the y value at pi over 3? And you'll notice that the sine x stayed the same, the cosine x stayed the same, sine x stayed the same, cosine x stayed the same. So if it had an x there, it just remained. Anything that had an angle was evaluated. Now I'm going to do some algebra. I'm going to collect like terms and simplify. I have a negative root 3 over 2 sine x and a positive. So those add together to get 0. I have a half cosine x plus a half cosine x. 1/2 plus 1/2 is 1. Well, that looks like a question that we're more familiar with. So what is this asking? At what angles are the x values root 3 over 2? So at what angles are the x values positive root 3 over 2? So positive x values are in quadrant 1 and quadrant 4. Those are our two answers in that domain.